this? How would you think about this in terms of dots and lines? What would you do? What would you draw? Right? What would represent the land? How would you represent the bridges? What would you do? So this drawing right here, let me just re-emphasize that bridge right there, here, bridges. This is often represented by a drawing that looks somewhat like that. What you might see is a little sketch of rivers, for example, the river coming in. It's not drawn exactly like the map, but that's okay, right? So we might see that right here. The rivers are coming in, and they connect right here, just as they do right here. Right? You can see it's somewhat the same. So this is the rivers, and then what you see are bridges. So let's draw those bridges in. Right? One bridge is right here, and that's this one right here. One connects the land here and here. There's another bridge down here, which is often represented like this. And that is essentially the same thing, right? That bridge connects the land, this empty space is land, to this space right here. It's doing the same thing here, just drawn down a little bit. And then two bridges here, which sometimes can be drawn like this and up here, just to emphasize that those bridges are actually separate. So this is what you might see in a textbook, right? And we'll draw these bridges in a little bit thicker. So it's the Seven Bridges of Konigsberg. I'll spell that, Konigsberg, which today is Kaliningrad. Okay, so Euler saw all this, and he realized that you can draw this into a graph. And before we even talk about the solution, this is such an amazing idea, and it's just so brilliant that it has to kind of amaze you that there's a way of doing this. And what he did was to draw a dot here. And I'm not going to say what that is yet, but then he drew 3 lines. This is like classic problem. So dot with 3 lines coming from it. And then we have a dot down here. And another one. And another one. And then a couple more lines. And we're done. This picture, this is why graph theory I think is so interesting, is able to represent this problem. Let's talk about how. I'm going to redraw the dots with green to represent land, because the dots, what they represent is land. Whether it's an island or a continent or whatever, that's a land mass, right? This is land right here, and you can see it right here. This is the land mass. Now from that land mass, there are how many bridges? 1, 2, 3. So these lines, what do they represent? Well, they represent the bridges. Okay, and then these 3 dots, what does that represent? Well, that represents the 3 pieces of land. The bottom dot represents this land right here. And notice that bottom dot has 1, 2, 3 bridges coming from it. 1, 2, 3. This middle dot represents this island right here. And notice that it has 1, 2, 3, 4, 5 bridges coming from it, as it does having 5 lines. 1, 2, 3, 4, 5 lines. And this land up here also has 1, 2, 3 bridges coming from it, or 3 lines. So he was able to represent this picture, which is based on the map of the actual city, and simplify it into this graph. And it's such a powerful tool to be able to do that. Now the question is, can you do it? Can you start at this landmass and then maybe somehow walk here to the end to all these other landmasses by only crossing each bridge